Well, welcome to video 12 on step graphs. And you'll see this is just a small example of a piecewise function. Okay, so you've done piecewise functions. Step functions are a very specific case of piecewise functions. And you may recall with piecewise functions that often they're continuous. A step function is almost certainly not going to be continuous. And so, in this case, hopefully you can see maybe why that's going to happen, but let's sketch the step function and see what happens. So I'm going to start with my axes. Just draw my two lines. I'm working in the positive here. And I note here that my x goes from 0 to 10, my y goes from 10 to 50. So I'll start y at 0. It just needs to go up to 50. And then I'll just pop in some lines to represent the 10s. And then I need my x to go up to 10, and I'll do the same thing, 2, 4, 6, 8. So there's my step function set up on a graph. So now what I'm going to do is sketch each of these components. But the thing with the step function is it represents situations where there isn't a linear component. Things cost a certain amount for, or I say cost, it could be anything, but let's say cost, for 0 to 4 of those items, or maybe this is continuous, and then it steps up. So it doesn't gradually increase, it just steps, or maybe it steps down depending on the context. In this case it steps up. So for 0 to 4, whatever it is, it represents 10. And this is my 10 line here, and so 0 to 4 is that part of the function. And then from 4 to 8, it's 20. So there's 20, it goes from here to there. And then from 8 to 10, it's 50, and so 50 is right up here, goes from here to here. Now the only thing I would say is, of course, we've got these guys here which are greater than but not equal to. So functions start here. This one starts at 4 with a greater than but not equal to. So you should have an empty circle around it to show that if you're at 4, we're on that guy, and we're not quite on this guy yet. But 4.0001, just above 4, is in here. And the same up here, we should have a little empty circle on that guy too. Rather than that filled in dot that I put when I was first setting this function up. But there we have it, a step function. Just make sure that you pop your x and y on each axis and you've got arrows in the appropriate places. This clearly has a restricted domain though, starts at 0, finishes at 10, so we don't need any arrows in the actual function. Okay, so let's have a look at an example. So this is the information from our example. We have a cost function related to the number of gym memberships. And this is a decreasing function, so it's actually what we expect, but we've got to be careful. If I buy 7 gym memberships, that doesn't cost $100, and then 15 costs 70. That would be silly, because it means that as I increase, the total cost goes down. This is the cost per membership. So 7 gym memberships will cost $700, but 13 will cost 13 times 70. Now you will find sometimes it means that 11 gym memberships is cheaper than 10, because we get that crossover where the price has gone down. Or sometimes we might get it defined as the first 10 cost 100, and then any subsequent membership costs 70, etc., etc., which means that there's no jump back down. But for now we just need to represent this function. It's a pretty typical situation, a corporate gym membership deal with a local gym. So I'm going to sketch this step function because that's all that's being asked in this question. So we have cost, and we have x, which is our number of gym memberships as defined in this question here. And I need to go up to 100, that's our highest, so 100 is there. And I'll just mark 50, and we can mark 70 when we need to. And x goes up to 20 and above. So I'll put 20 about here so there's room to show the above. And 10 is about here. So we have the cost for 1 to 10. So I'm going to be really careful not to denote 0. Because if you're buying 0 memberships, it doesn't really make sense that we have a denoted cost. So I'm going to start with a dot here at 1, and I'm going to go out to a dot at 10. It's appropriate to dot in this case because it's greater than or equal to 1, less than or equal to 10. But at 11, we start at 70. Now this is discrete data, so I could have 11 in X is greater than or equal to that. So I don't buy 10.5 memberships, so it's discrete. So you could have either of those representations, and maybe the 11 is a better way of representing it. But either way, because it's got 10, I'm going to start at 10, but with a circle. And then I'm going to run up to 20, but 20 is with a dot, and I've gone down too low, because that's $50, but it should be 70. So let's rub that out. Try this one again. So I'll start at 70 there, with a circle, and go along to 20 and fill that dot in. And then I've got greater than 20 as $50, but it's greater than, so I'll start there with a circle. And I put an arrow in there because it just says greater than 20. It doesn't have an upper bound, so it finishes with an arrow. There's my step function. That represents the cost of going to the gym within this corporate membership deal. Now, it's not a lot of detail. Maybe it's probably cost per month. We don't know. And that doesn't matter too much because we're just dealing with the math side of things. And it would only matter if we then need to come back into the question and answer certain things related to the cost. Anyway, there we have it. Well, thanks for watching this video. All the best.